Okay, so let's take a look at reaction yields, which is the next part of stoichiometry. So in stoichiometry, we saw that we can figure out how much product we're going to make, how much reactant we're also going to need. So if I start with, or if I want to produce X amount of product, I know what I need to start with. So basically, we can convert any chemical into another chemical. So I can tell you, if I give you one, if I want to make, 7 portions of my toffee, I know exactly how many ingredients I'm going to need. If I only have two sticks of butter, 4 sticks of butter, I know exactly how much product I can make. So, but reactions are not perfect. Reactions, their side reactions occur. We're limited on the starting materials that we have. So all of these things end up altering what we actually produce. So we have to talk about the concept of limiting reactants. So limiting reactants essentially is just one of the reactants. There's always one limiting reactant that will limit the amount of product we can form. So let's say that we have, let's say that we're going to make some sandwiches, and we're going to make some cheese sandwiches, delicious cheese sandwiches. We have a reaction of 2 slices of bread plus 1 slice of cheese, and we're going to put some holes in it. Maybe it's going to be Swiss, whatever, yields 1 fully formed sandwich. Okay, so if I were to tell you that actually we have 32 slices of bread and we have 14 slices of cheese, how many sandwiches can I make? How many sandwiches can I make with that? Well, you would just do some math in your head and say, all right, well, let's see. So 32 slices of cheese, or slices of bread. So if I divide this by 2, I would end up with 16 total sandwiches is what I could make total. Right, so 16 total that could make. And we only need 1 slice of cheese, so 14, we could actually make 14 out of this. It's 14 total. Well, which one limits the reaction? If I just start making sandwiches, once I use up all of the cheese, I have essentially made 14 sandwiches and the job is done. But what do I have left over? So this ultimately, the cheese would be my limiting reagent or limiting reactant. Okay. The bread, I would have how much bread left over? Well, if I made 14 sandwiches, I would use 28 pieces of bread, meaning that I have 4 pieces of bread left over, 4 slices of bread left over. We would call this thing the excess reactant. If you have many, many reactants, there's always one limiting reactant, everything else is an excess. So that is the concept behind limiting reagent or limiting reactant. There's always something that's going to stop the reaction from continuing because you've run out of it. Okay, so we're going to skip this one. I'm going to let you guys do that one on your own. We're going to do that one in class. We're going to take a look at this problem here. Peroxide, H2O2, is used as a cleaning agent in the treatment of cuts and abrasions. Small quantities can be prepared by the following reaction. What amount of H2O2 should be produced from 1.50 grams of barium oxide and 0.68 grams of HCl? So we have 2 starting materials. We don't know based on their masses because masses are not the same thing as moles. So before we start this, the first thing that we want to do is we want to calculate out. Again, we want to put in the molar ratios, and we want to figure out the molar masses of all these things because we're probably going to need them or we're going to need some portion of them. So we're going to do this. Actually, I'm going to pause this. I'm going to write them down. You should do the same thing. Okay, so this is what I calculated out. Barium hydroxide, BaO2, 169, HCl 36, H2O2 34, and barium chloride as a product is 208, 23. So what amount of H2O2 should be produced? So this is our target. So we want to solve for H2O2, which means that both of our starting materials, we're going to do two separate calculations. I'm going to take the 1.50 grams of barium oxide, and I'm going to solve for how much H2O2 we produce. I'm going to do the same thing for HCl. Whichever one produces less, that one had to limit the reaction. That one had to stop the reaction from continuing. Okay, so for we'll do them in, so for barium hydroxide, BaO2, let's take a look. So 1.50 grams of BaO2. And again, I want to work towards getting H2O2. So first thing, before I can switch chemicals, talking about barium hydroxide, I need to convert to moles. So grams of barium hydroxide to moles. So 1 mole is equivalent to 169.33 grams. All right. At this point, again, grams would cancel and I would be left to moles, but of course I want moles of barium hydroxide to, now we're using molar ratio. Again, so the first one was the molar mass. This is molar mass of barium oxide, or barium hydroxide rather. Yeah, barium peroxide, I should say. This is going to be molar ratio. And then finally, it's going to be molar mass of my peroxide. So moles of, we want to convert into H2O2. And 1 mole of H2O2 is equivalent to 1 mole. That makes life easy. Our units cancel. Moles of barium oxide, barium hydroxide cancels. And then finally, I want to convert into H2O2. So moles of H2O2 over grams of H2O2. So 34.01 grams over 1 mole. And then finally, moles of H2O2 cancels. Let's do the math. And what do we get? So let's take a look. And I'm going to pause this again and do the math quickly. Okay, so I end up with, after doing the math, you end up with 0.3 sig figs, 301 grams of H2O2. Okay, so that's how many grams of H2O2 I would have if I started with a limited supply of the barium peroxide and excess HCl. And now we're going to look at it the other way around. I'm going to say, all right, so what happens if I start with 0.68 grams of HCl and it completely reacts? Okay, so yeah, why don't you pause, try to figure out how much peroxide you'd end up with, because I'm going to as well, and then this will all be written out and we'll see if you got the same number. Okay, so here I have it written all out, and so let's walk through this. So I start with 0.68 grams of HCl. First thing I want to do is I'm going to cancel out grams and I'm going to convert to moles of HCl. And then being in moles of HCl, it allows through molar ratio to convert to moles of peroxide. Moles of peroxide cancels to give me grams of peroxide. So you do this entire calculation, we end up with grams of H2O2. If HCl were limiting and everything else, and we had enough barium peroxide, and we end up with 0.317 grams. Okay, 0.317 grams of peroxide. So which one produced less? Okay, so the barium peroxide has got to be the limiting reactant, because this is how much it could produce. 0.301 grams is the maximum amount that it could actually produce. Okay, so that's it. That's the limit. That is what we would call our theoretical yield. Because the limiting reactant will always provide you with what yield you would be allowed to have, right? Assuming no side reactions, assuming all of the barium peroxide in this case react, you would end up with 0.301 peroxide as a result. Well, what about that 0.317 grams of H2O2 from the HCl? most of the it looks like most of the HCl is going to react, but there is going to be a bit of it left over. So now we have to figure out how much HCl remains unreacted. So the second part of this is, all right, so I know that at the end of this, I'm going to have 0 grams of barium peroxide. So the result of the reaction equals 0 grams of BaO2. I know that because it's the limiting reactant, we should have nothing left. However, looking at the HCl, let's start with our 0.68 grams of HCl again. Not all of it can react. So how we do this is we essentially say, okay, well, if that's how much HCl I start with, what we actually want to do is we want to figure out how much of it reacted. So we start with this much. How many grams of HCl reacted? And then how many, if we subtract those two, how many grams of HCl remains unreacted? So we have to figure out ultimately what we're looking for is the number here to complete this idea. How many grams of HCl remain unreacted? Well, again, because barium peroxide is the limiting reagent, we are going to use that as our starting point. So I have 1.50 grams of barium peroxide, and I want to convert that into X number of grams of HCl. So we're going to figure out how many grams of HCl actually is needed by the barium peroxide. Okay, again, because I can convert it to anything I want. So if I start with 1.5 grams of barium peroxide and I convert it to grams of HCl, I know how much I would have needed in order to react at all. So let's take a look. So 1.50 grams of barium peroxide. And again, this whole thing is set up the exact same way. So grams of barium peroxide over moles of barium peroxide. By the way, I'm calling it peroxide because O2 is actually O minus 1 because barium is 2 plus. All right, so moles of barium. BO2, moles of HCl in this case, because I'm trying to solve for moles of HCl, and then moles of HCl over grams of HCl. So going back to my table, barium oxide is 169.33 grams for 1 mole. 2 moles of HCl for every 1 barium oxide. 1 mole of HCl is equivalent to 36.46 grams of HCl. So there we go. Now let's just quickly do the math. And again, we're just going to simply work through it. Again, doing multiple in a row allows me to cancel and see what unit. This is why I told you dimensional analysis is so important because it's used all the time, especially doing these types of calculations. So 1.5 divided by 16933 times 2 times 36.46 gives me 646 grams of HCl was used. So now I can plug this in 0.646 grams. So 0.68 minus 0.646. Again, let's try it again. I can probably do this math, but I don't feel to. It's Sunday. 6.8 divided by 0.646 gives me 0.034 grams of HCl. So at the end of this, I have 0 grams of barium peroxide and I have 0.034 grams of HCl remaining. This is what remains unreacted. Okay. Again, we always start with our limiting reagent. Once we know what our limiting reagent is, then we can solve for everything else. So our theoretical and percent yield, because life is not perfect. So here we have and I'm just going to take this number here. This was our theoretical yield. Theoretically, we should end up with this much. Okay, so theoretically, we should end up with a yield of 0.34 grams. Okay, 0.301 grams. But again, life is not perfect. So the actual yield in most cases is typically much lower. So theoretical yield is going to be calculated based on limiting reactant. Experimental yield is what you'd get from experimental, so the results of an experiment. There's plenty of reasons you get a smaller yield. The experimental yield could be smaller because you have side reactions going on. The experimental yield could be smaller because some remained in solution. The experimental yield can actually be larger than the theoretical yield because you didn't purify it properly and you have some leftover salts or something like that, or you have water that's in there still. So experimental over theoretical times 100 is going to give you your percent yield. So if my experimental yield for this is 0.290 grams, we're just simply going to figure out the percent yield by plugging those values in. So 2.90 grams is my experimental over 0.301 grams of my theoretical times 100. So 0.29 divided by 0.301 gives me a times 100, 96.3% yield. Not perfect, but actually pretty decent. So 96.3% yield. Okay, so that's how you calculate a theoretical or a percent yield based on what you expect, but what you actually get. Okay, so now I've got a bunch of problems for you guys to do and to do those calculations, figure out what the percent yields are, and then we're going to finish up with quantitative chemical analysis. And this is probably going to come in the next couple of days.